Okay, so now I'm gonna help you with these problems that I gave you. Look at number one there. A sidewalk is made of three congruent rectangles, okay, and one isosceles trapezoid. Remember what this word isos means two, so that means two sides are the same, okay? That means these guys are the same. So now think there, this guy and this guy are the same measurement. What is the total area of the sidewalk? So we have a composite figure because we have this whole figure. Within this whole figure, we can decompose. In other words, we can break it down into figures that we have equations to find the area to. Because right now, the way it is, I don't have an equation for this. But if I cut it up, decompose it, I have three rectangles there. I can see them. And I also have, of course, the isosceles trapezoid. So I think there, well, I know the formula to a rectangle is just base times height. And I know this is the base. Well, I know this is the height because this is 3.5 and this is 3.5. And they're all the same. So if this is 3.5, 3.5, 3.5, this is also 3.5. I'm going to put it in decimal form, 3.5. To find the area of a rectangle is just base times height, which is 6 times 3.5. Okay, and then that'll give you, okay, 3.5 times 6. 6 times 5 is 30. 6 times 3 plus 3 is 21. One number to the right of the decimal, 1. So I know this is 21. You have three congruent rectangles. Three congruent rectangles. So that means you have three of them. And now let's look at the trapezoid. Well, I know the trapezoid formula is base area is equal to base 1 plus base 2 times the height divided by 2. I know my two bases are here. Base 1 plus base 2, or this could be the base 1. Doesn't really matter because remember you're adding together. So 3.5 plus 7. The height, now the height is the one that connects the two bases. And it's a right angle, it forms a right angle with the two bases. So then the height is 4.5. And we have to divide by 2. And so now 3.5 plus 7 is 10.5. Times 4.5 divided by 2. Okay? And so multiply these two and then divide by 2. Add it to this. Now remember, this is 21. Well, if they're congruent, then this is 21. And this is 21. And so now you got to figure it out. This plus this plus this plus what you get here is one of your answers. Okay. Number 2. Kyle will repaint one side of his skateboard ramp. Okay, as you can see, it's a ramp. So let's see here. He's going to paint the area he will paint is shaded in the drawing below. Okay, so to the nearest hundredths of a square meter, what is the area that Kyle will repaint? Okay, so think there. What could I do to figure this problem out? Well, this funky figure here, I don't know what that is. I have no idea what that is. But I know I can make a rectangle by connecting that. Now I have a rectangle. Okay. Now I know if this is 13, then I know that from here to here must be 13. But look at what it says there. This is 0.5 and this is 0.5. So if this is 0.5 and 0.5, 0.5 plus 0.5 is 1 together. So then 1 plus, that means that from here to here must be 12. Because 12 plus 1 will give me the 13. Okay. So think about that. Now, I have a rectangle here. Because if I connect this line, then I have a rectangle. But I also have a half a circle right there. That's half a circle. I know that the line all the way across that runs from one side of the circle to the center and then all the way across, that's the diameter. So 12 is the diameter. Well, to find a half circle, we would use the area of pi times radius squared. That's for a whole circle. But since I have half a circle, I divide by 2. And so pi is 3.14. The radius is half the distance of the diameter. Well, the diameter is 12. Then that means that the radius is half, which is 6 squared. Okay, that'll give me the area of the half circle. I'll multiply this out. This gives me well, I won't do it all. I'll just do 36, and I'll leave it like this. You have to figure this out. This will give you the area of the circle here, the half circle. Now, to find the area of the rectangle is just base times height. Base times height. It gives you the dimensions. 13 times 6.5. That's the area of the whole rectangle. You don't want the whole rectangle. You just want the shaded part. So think about what you need to do. Are you going to add these two together, the answers, or subtract, or divide or multiply? Think about it. I want the area of this. I'm gonna paint this. I'm not gonna paint this. This is where the skate is. Remember, he's skating, so you don't have to paint this part. But I needed to find out the rectangle to find the area of how much this is. So the area of the rectangle, you multiply this 2 and you get the area of the whole rectangle. You multiply this and divide by 2 to find the area of this half circle. In other words, this empty space. Once you have this empty space, well, what are you going to do? Think about it. So find the area, find the area. Number 3, you have this here. You have looks to me like a triangle. Okay. No, doesn't work. So that's a triangle there. Okay. And then inside this triangle we have this funky figure. It's not a half circle, because if I make the whole circle like this, that's not a half circle. That's actually a quarter circle. Okay, so it's 1/4 of a circle. Okay, it's a quarter circle. So now think about this. A triangular piece of wood was cut as shown below. A triangular piece of wood. Determine the area of the shaded region to the nearest square centimeter. So we want this part. I want this part. This is what I want. The shaded part. I don't want this space. But we need to find the area of both figures to get the area of only the shaded part. I don't want this, I just want this. I know to find the triangle, it's base times height divided by 2. Well, look at the triangle. Base times height divided by 2. What two measurements hit each other and make a right angle? Is there a right angle here, or right angle here? And of course, this is where the two lines connect at the vertex and make a right angle. This is an acute angle, this is an acute angle. That's why you want to use this. And 15 by what? Well, this is 9, this is 6, so total is 15. So from here to here is 15. So 15 times 15 divided by 2 gives you the area of the whole triangle. You don't want the whole triangle because you want to get rid of that. So the area for a circle is pi times radius squared. That's for a whole circle. You don't have a whole circle. You have a quarter circle. You have, there's 1, 2, 3, 4. You have 1/4 of it. So then you must divide by 4. Once you have this, pi is 3.14. Well, what's the radius? The radius is the distance from the center of the circle to the outside. And so as you can see, this is 9 right there. Okay, this is also 9 here. Okay, because from here to here is 15, but this is also 9. So then it's here 9 squared. Okay, so now this will give you, it's not 9 times 2, it's 9 times 9. So it gives you 81. Okay? Figure this out. Figure this out. So you gotta figure this, you gotta figure this. This is just arithmetic. You should be able to do that. Number 4. Number 4 there. Oh, sorry. Number 4. The shape contains an isosceles triangle with a height of 8 centimeters. Okay, so determine the area of the shape to the nearest tenth of a square centimeter. So we have this shape here. We have an isosceles triangle. So I'm going to highlight the isosceles triangle. Okay, that's the isosceles triangle. I know isosceles means two sides are the same. That's why hence the two sides are the same. Okay, isosceles triangle. And then I have two half circles that are the same because they both have a measurement of 10. Those half circles are the same. And so think there. I have two half circles that are the same. Okay? You also have another half circle, but it's not the same as the other two because this measurement is different. Okay? So now to find the half circles, it's just area is equal to pi times radius squared. Because it's a half circle, well, let's look at this one. If this is a half circle, then you would have to divide by 2 because you only have half of it. Okay, for this one, divide by 2. Now here, the triangle part, area is equal to base times height divided by 2. Base times height, base times height divided by 2. Your base and height must touch at a 90-degree angle. That's why we wouldn't use 10 and 12 because that's an acute angle. So it's not 10 times 12 because that's an acute angle. This vertex here, where this line and this line hit the vertex, that's not a right angle. Same here on this side. Where this line and this line hit at the vertex here, that's not a right angle. That's an acute angle. But where this line and this line hit, it does make a right angle. So that's my base and height. And so this one would be 12 times 8 divided by 2. Figure this out, you get the area of the triangle. You have to figure out this one here. Well, what does the 12 represent? It's going all the way across from one side to the center to the other side. That means this is the diameter, so this is the diameter. So then I'm going to put, okay, so 3.14 times the radius, that's the diameter, the radius is half of this, so it's going to be 6 squared. Okay? We've already done this problem before in the other worksheets. Look it up and you'll get the answer to that. Okay? And now the other one that I have here is this. 2.5 circles. Think about it. What if these 2 half circles can I put them together and make one circle? So I can use this equation just the way it is. This is the area for one full circle. Well, these 2 make one full circle. So then 3.14, what's the radius? Well, all the way across is the diameter. So half of that is the radius. And so figure that out. So find the answer to this, answer to this, answer to this, add them together because I need to know all the areas combined. Right? Number 5. Number 5 there, we have a welder. He's going to cut his shape from a sheet of metal. Determine the area of the remaining metal. Look at that, remaining, automatically, subtract. So we have a sheet of metal. So let's look at the figure there. Of course, well, they cut out a trapezoid. Looks like a trapezoid to me. It looks like a trapezoid to me. Okay. So I know that I'm going to have to use the trapezoid formula, which is area is equal to base 1 plus base 2 in parentheses times height divided by 2. Everything looks well. I have a height, I have a base, but I don't know what this base is. Okay, so I still need to figure that out. I also know that the sheet of metal is in form of a rectangle. If you look at it, that's a form of a rectangle there. So it's a form of a rectangle there. So I know the form of a rectangle is just base times height. And so think there, well, you have a base, because if this is 12, then this is 12. If this is 2, then this is 2. But look at the units of measurement that they give you. Feet, yards. Feet, yards. To know what you're going to convert to, because you need to have one form of unit of measurement. It's either all feet or all yards. Look at your answer choices. They're all in square feet. So guess what? Let's convert everything to feet. So you have this in feet, you don't have this in feet. So if this is 2 yards, I know that 1 yard is equal to 3 feet. So if 2 yards, that means I have 2 of these. That means I have 6 feet. Okay. And so now you just base times height, or base times height, gives you the area of the whole rectangle. That gives you the area of the whole rectangle. But then you're going to cut this piece off, but you need to know what this measures. Well, if this is 1 yard, what is this in feet? Well, 1 yard is equal to 3 feet. So that must be that this is 3 feet. Now, if this is 3 feet plus what gives you 12 feet? Because look, this is a parallel to this guy, so that means these two guys are the same. This line and this line are parallel. So this guy is also 12. But this is 3. Well, 3 plus what gives you 12? Well, 3 plus 9. So that means this is 9 there. 9 feet. And so now I can use my equation, base 1 plus base 2, base 1 plus base 2, or this one could be base 1. Base 1 plus base 2, so I'm going to put there 4 plus 9 times the height, well, the height is right there, times 3 divided by 2. And so now this is just, arithmetic. Figure this out. Think about it. I want to know what's left over. You're going to cut this piece out. Think about it. I'm cutting it out. If I cut something out, think about the operation. What's the remaining? Think of what that means. Remaining. I only want this. I don't want this. I already cut it out. Ya no está ahí. So think about it. Okay, look at the next one there. Melinda used 2 shapes of fabric in a quilting pattern. What is the area of the combined? Combined pieces. Combined, you should know what that means in math. Combined pieces. Whenever you see the word square inches, think of area. So, is this an area problem? Well, what are the 2 figures you see here? I see a triangle there, but I also see, I see a triangle, but I also see this. It looks like a rectangle that's slanted. Well, that rectangle that's slanted is called a parallelogram. The formula for a parallelogram is just like a rectangle, because it is a rectangle, it's just slanted. So it has the same, I want to say the same factors, I guess the same, it has base, it has 2 parallel sides is what I'm trying to say. Okay, just like a rectangle, 2 parallel sides. So this is just area of base times height. This one here is base times height divided by 2. Okay. This is 3.5, so make it 3.5. Now this is 5. That means by rule, because the parallelogram, opposite sides are congruent, or parallel sides are congruent. So this is 5. So that means this is 5. And then from here to here is 5. Well, that means from 7.5 is from here to here. So think 7.5 from here. So 5 plus what gives me the 7.5? Well, 2.5. Right? Because 5 plus 2.5 should give me 7.5. So this is 2.5. 2.5. And so now this is just base times height divided by 2. And then here, what if I make this line here coming down this way? And I put the little cuadrito that makes the 90-degree angle there. Okay. Remember, your base and height must meet at a right angle. So I didn't use this one because look, that angle's acute angle. I didn't use this one because that's an acute angle. So I made an imaginary line coming down. That's my height. Well, that is parallel to this guy. So how much does this one measure? Okay, and then you will multiply. Well, if this is 3.5, then that means this is 3.5. And so now think, what's your base times height? Base times height, and you get the parallelogram. Okay, and then you get the answer. Figure it out. Number 7 there. Okay, you have this. He has a wall in his workshop. See, P cut a square window in the wall of his workshop. The window side length measures 18 inches. What is the area of the wall excluding the window? Mira, esta palabrita aquí. Excluding. That means you got to take away. Think of what the operation means. Take away. So now the problem here, again, we have the same thing in the other one. Our units of measurements are not uniform. They're not the same. This is yards, inches. So we need to make them the same. But let's look at the choices to see what they're in. They're in square, they're in yards. So guess what? I'm going to leave my yards alone. I'm going to convert these to yards. So, and this is a square because it tells me there, square window. So then I'm going to here, I know 1 foot is equal to, I'm sorry, 1 yard is equal to 3 feet. And I know in 1 foot, there is 12 inches. So then 1 yard must have 3 times 12, which is 36 inches. So now 1 yard is 36. So if I have 18, I have a total of 18 out of how many are in a yard? Well, 36. So how much is this? If I simplify this by 2, what else can I use? Okay, by 9. 9 goes into 18, 2. 9 goes into 36 4 times. I can simplify this by 2, and I get 1/2. 1/2 is the same as 0.5. So that means that this guy is 0.5 yards. And that means this guy is also 0.5 yards. Okay? Because they're the same. And I'll put on the side. 0.5 yards. Okay? So now, if I find the area of this little window here, its area is equal to base times height, or the whole rectangle is, again, area is equal to base times height. Okay, use these two formulas. We'll figure it out. Remember, this is 0.5. Okay, all sides are 0.5. Okay, so think about it. If it's 0.5, this number here. Okay, that's what this is. 0.5, 0.5, 0.5. Base times height. Think about this. And what are you gonna do after that? Think about the word excluding. Okay. Next one. This is not. I'm not gonna do this one because this is just, put it there. Okay. Find the rectangle, quarter circle. Okay. Figure it out. If this is 2, then this must be 2 because it's 4. Well, that's my radius. Okay. Think about that. Number 9. We have this. I want to know the area of this whole figure. Again, look, you have rectangles. Hurry. Rectangle, add them all together. Find the area. I gotta use this.
Just a couple of announcements. Reminder, attention book club members, there will be a meeting tomorrow at 7:05 a.m. at the library. Please be prompt and don't forget to bring your Magnus Chase book. Also, reminder for FCA will be on Wednesday, that is tomorrow, from 4:30 to 5:30 in the school cafeteria. Don't forget your permission slip. If you still need a permission slip, you can pick one up at the front office, library, or Ms. Ward's classroom. See you tomorrow.
So it's a parallelogram.
Once again, we are continuing with the attendance competitions between the grade levels that will be announced for next week at the end of the week. Also, if students, if you need to be staying for tutorials, please make sure to do so. Again, athletes, if you're coming in from the locker rooms or changing and then heading over for after school supper, you must have shoes on when you come into the cafeteria. Please make sure that you take care of this before you leave the locker room. If you are waiting around for tutorials and after school supper, you need to make sure you are sitting down in the cafeteria, as we do have a lot of traffic come in through the cafeteria to either be walking home from school